This video is about stereochemistry and biomolecules. So the keyword in the question is cannot and enantiomers. And the concept of this question is how to identify properties of enantiomers. So here we have a general formula of a amino acid molecule. And to form an enantiomers is to have a mirror image molecule. So we have a mirror plane of another molecule that is exact mirror image of the first one, which would be something like this. And so these two molecules right here are enantiomers of each other. And the molecule itself needs to have a property called chirality to be able to form enantiomers. And that right there in this example is in a form of a chiral carbon, which means that each of the bond that it's made, the group of molecules or atoms that it is bonded to are completely different from each other. So you can see how there are 4 bonds and it's 4 different groups. So here we have a hydrogen, a COOH, a R group, and an NH2. So if we were to replace R with, for example, CH3, and we would have CH3 on this side as well, you can see that they're mirror images, obviously, but if you were to fold them on top of one another, they will be non-superimposable, because the H, this molecule here, when it is flipped around, the H would actually be in front and the CH3 would be behind. So you can obviously see how they're not the same molecule. They're only mirror images of each other. But if we were to have a hydrogen in place of the R group, if we were to flip this molecule around, we would have this H would be in front and this H would be behind, which will be exactly like this molecule. And they won't be mirror images anymore. They will just be the same molecule. So in this example, there's no chirality. This is no longer chiral carbon because it is bonded to this 2 of the same atoms or the same group of molecules. In this case is 2 hydrogen. So if we were to go back to our question, to identify which amino acid cannot exist as enantiomers, we need to identify which molecule doesn't have a chirality or a chiral carbon. So the first one, the carbon here is a chiral carbon because it is bound to 4 different groups of molecules or atoms. In question B, the carbon here is not a chiral carbon because it's bonded to 2 of the same molecules or atoms. In this case, is 2 hydrogen. So B is our final answer because it does not have a chiral carbon and therefore it cannot exist as enantiomers.